Ladies and gentlemen, good morning to another video from the headquarters here from Lucas-Nuelle in Kerpen. At my side again, my good friend Daniel. Good to have you finally back. So
Finally found a bit of time to do a video again. So
yeah, awesome. So felt like it's 2 years ago the last time, but it's not that long. But anyway, last time we have talked about interlocks and service plugs and everything what belongs to it. We will link that video somewhere here if you are interested in that. But today we're gonna talk about what is, for example, controlled by the interlock, but also by many other stuffs. It's the high voltage relays, right?
Exactly. So they have many different names. Some people call them the contactors because they're very big contacts inside.
Okay.
Essentially, they are very big relays. So Toyota, for example, call them system main relays. Yeah, like I said, some call them contactors, main relays. Lots of different things. Essentially, what they are doing, however, is breaking that contact between the high voltage battery to the rest of the vehicle. So it's one of the main safety orientated systems that we have in the car. That's why it's connected together with the interlock. So when the interlock is opened, meaning that someone has opened a part of the high voltage system, these contactors should open immediately and separate the high voltage battery from the rest of the vehicle.
Interesting what you said as you used the word should. As we know, like a little X-course, which is pretty important for older cars or cars which are in an accident, that these things, of course, can also be welded shut, right? Maybe
Exactly.
a quick word, what is that?
So welded shut. So imagine, so here's one of the relays that we've opened up. So essentially that comes from inside here, like this. And these are actually Panasonic relays. They're the ones that are often used by Toyota, many other different types
It's
of
really
brands.
massive.
Yeah, absolutely. So they're, again, real relays. You can see inside here the core that opens up, that gets pulled up into the magnet of the coil here.
So that means you have here the control current running over it?
Exactly, the control current, which is basically the current going through to this coil here.
As we have learned in school, this creating then a magnetic field?
Yep, exactly. So either pulling towards or pushing away, depending on which way the current is going through the coil here. But inside of this point here, we can see that we've got two contacts. So one side coming in from the battery, one side coming out from the battery. And at the moment, they would be open circuit. And then when we create the contact, then there'll be a contact going through.
Okay.
The main thing is that what you spoke about when they get welded shut is we can often have high current within electric vehicles, especially during that initial startup. You've got these massive capacitors inside the inverter.
Yeah.
And capacitors can soak up so much energy that they're almost like a short circuit. So you have, in this case, something called a pre-charge circuit. So normally what we'd think, if we've got a high voltage battery, we've got high voltage positive, high voltage negative.
Yeah.
And that means that completes the circuit through the thing. And we've got a contactor on both sides. What we have in this case, however, is a pre-charge circuit, which is a resistor inside which closes before either one. There's a few different generations now.
As usual.
The classic is the pre-charge is on the high voltage positive side. So instead of just having a full, without any resistance, there's a resistor on the pre-charge side which slows down the amount of current.
So that means they could be a little bit smaller, not that thick and strong, these pre-charge relays. I think you have also brought some of the pre-charge relays with us.
I've got a couple of them here. That some of the older ones were like this, however.
Okay.
So they did use that. I've got a couple of the modern ones here as well, pre-charge resistors.
They look
it's not resistors.
really tiny.
Yeah, exactly. So something to perhaps look out for on modern vehicles. It's basically, it looks like a normal relay. The big difference is here. I don't know if Leon can zoom in close enough here to see it, but there's actually there's a high voltage warning sign on here.
Okay, which makes sense as it's part of the high voltage circuit, even when not high current is running over it.
Exactly. So that's on this side as well. Even this tiny little one, it's got contactors that, the pins. Bit different to the classic relay that you see here as well.
Really small ones, interesting to see.
So I've got to do some more research into these. I'm not 100% sure on where they're being used.
Yeah.
Some of the latest versions that we see for pre-charge resistors is through the DC to DC converter.
Yeah.
So that might be on that side. I'm not sure.
But in general, I think we can say we don't have high current over those guys here. But of course, what you said here, when we close or even when we open the high voltage circuit here, we have really high current running over those guys here.
Exactly. So and that's a good point. It doesn't matter when it's closed about the high current. It's
the moment of closing or opening.
Exactly, and you get that huge spark that's occurring that can pit the contactors. And so what you often find in a lot of these as well, especially the high-end relays, they'll be completely sealed here, and there'll be different gases
with
inside.
Gas, yeah, I've seen that before.
To extinguish that spark as well.
So that it even won't be created, basically.
Yeah, exactly. Coming back to what your original question was about them being welded shut. So through this spark, through the high current, often with faults or things like that as well. It doesn't normally happen, but it has happened in the past where these contactors will weld shut. Weld because of the current, the amount of current goes through there, melts the
So a really high temperature comes with it then?
Exactly, high current, high temperature, melts the contactors together and they stay shut. It's obviously a disaster if you're working on these vehicles because you can think, okay, vehicle's turned off. This is what happens when you press ready button. So you press ready button, it'll go through the sequence to activate these with the pre-charge and then with the main contactors, and then car says ready. So you would expect when the car is turned off, not in ready mode.
It's not ready anymore.
It's not ready anymore,
yeah.
And that voltage that we have in a high voltage battery is no longer at the inverter. So, and that's a part of why we do the isolation procedure.
Yeah.
Is when you isolate a vehicle to work on parts of the high voltage system, you trust but verify. So we've done plenty of videos on that. We won't go into that now, but there's something called the live testing. So that's where you're using your meters or your voltage testers to make sure that the system is actually de-energized.
De-energized and that the meter is still fine, right?
Exactly.
For the live.
Yep.
So even when we have this welded shut problem and we're going into ready mode or more going out of the ready mode, the car probably won't work anymore. So there is still the connection between the high voltage battery and the rest of the high voltage system is closed, but obviously the inverter won't work and won't be active when you shut down the vehicle. But on the other hand, that means then when we are coming back to the issue of the different qualifications throughout the whole world, doesn't matter, DGUV, ASE, IMI. That means then when you're looking on these different qualifications, when we have a car which has such a problem, so basically we cannot shut it down officially anymore, that is really safe. So that would mean, or is that right, that a person with, for example, a qualification for working on safe high voltage systems, who has the task to shut down the vehicle, is basically not allowed anymore to work on that vehicle when you have such a fault, as you cannot shut down the vehicle properly, right?
Yeah, exactly. So that's a good point. So what do you do when you do that? So we have other videos as well to show what happens when there's current flowing and you disconnect. So we talked about it just now. You get that spark occurring. The problem is when we shut this down now, there could be current still operating, flowing in the vehicle somewhere.
So it could be somewhere, exactly.
Could be somewhere. So there's different strategies for that. We spoke about the service disconnect. So you can imagine you pull the service disconnect, that's the high voltage service disconnect, that's normally inside the battery, and that separates the battery into two halves. When this battery is separated into two halves, you still have, what a lot of people don't understand is that you've got one battery that's got a negative and a positive output, but you've got all these cells in the middle to increase the voltage. So what you do is you separate that into two batteries. A lot of people don't understand, but I've still got this, I'm not disconnecting the, say, the positive side going to the contactors
Yes.
or anything. You're separating the other end of the battery, so now you've got an open circuit battery.
Yeah.
So that's also the same as shutting it down.
So it's basically just another position where you open the battery. So not
Exactly.
at the high voltage contactors, which cannot open anymore,
Yeah.
or at least one cannot open anymore. But it's then just on another position where you rip it apart.
Exactly, and it's got the added bonus that instead of now having, say, a 400 volt battery, you've got two 200 volt batteries, so lowering that risk again. But the problem is when these are still open, there is the possibility for current still to be flowing through the circuit. So if you disconnect that high voltage service disconnect, you might get the spark occurring there.
That would be my question. Is there any experience what happened then when you're still, or when you maybe the high voltage battery is of course not under load if you pull it, as we don't drive with 200
Exactly.
kilometers per hour, but it's still, there could be some kind of current flow. So the possibility is there that when you pull out the high voltage service plug while the connectors are welded shut, there could be a spark.
Exactly.
So definitely wear your gloves.
So a flash, that you often hear that, some of the terminology, it's not necessarily just a spark. Spark sounds a little bit
easy, yeah.
But a flash or an arc flash, and that's what you see on those YouTube videos where they're closing, you know, the high voltage power lines, all that sort of thing. The main problem that you have here is if you do that, you get that spark, you'll get a lot of smoke, and the big problem is if you're doing that close to you, your human reaction is to go like this,
Yeah.
and you can breathe in not only the smoke but the flames, if there is flames, or the plasma that's being generated, and you burn yourself from the inside. That's a big problem. So exactly what you said. If this occurs, you need a.
But not only the gloves, what you explained, then
Exactly.
even the whole PPE.
So you need a full face shield, a blast. The balaclava for the flame-resistant balaclava, flash protection, a full-faced helmet with the neck protection here as well, gloves, long sleeves, all of that sort of thing. It's where you also have the fiberglass pole.
Yeah.
The otherwise known as the service disconnect. The technician
disconnect tool. Yeah, you told me that.
Exactly.
So, but here again, because I can think that a lot of people will say like, "Oh, I've never seen that." I think that's a situation again. It probably won't happen in your whole entire life as a mechanic, but when it happens, it could be really, really worse.
Exactly.
And this is why you just wear this stuff, especially so. From my feeling, it would be like I would wear this when I'm working, especially on older cars or on accident cars, where I just do not know what happened there.
Yeah, I mean, in the end, it doesn't matter. You, like I said before, you trust but verify. You do it for every vehicle. You assume that it could be the case for every vehicle. One slight difference, what we just spoke about there, is a lot of modern vehicles are going away from having a service disconnect.
True, yeah.
Manufacturers don't want people, even trained technicians working on or playing around with the high voltage side. So they're removing that manual service disconnect.
So you can also see that in the video what we have done. We will link that here, where is the low voltage service disconnect.
But the low voltage service disconnect doesn't help us in this case if the contactors are welded shut.
As the low voltage service disconnect is not part of the actual high voltage system or high voltage circuit. So that means when you pull the low voltage service disconnect, it's more like a trigger which tells the system.
All it does is turn these off.
Turn these, okay, like they don't get the power, they cut the power.
Get the control signal.
But when it's welded shut, it doesn't matter. Yeah.
Exactly. So that's the next big issue with that. And so what those manufacturers have in those cases, because then you literally can't do anything. There is no manual service disconnect to remove. What they have is a pyro fuse in the battery then. So that's you can imagine that it's similar. It's not a contactor. It's complete, but it's a little unit similar to this, but it's got a little explosive charge in it. And that blows the contactor, or it blows, like there's a little bit like a fuse, but instead of burning the fuse through current flowing through, like a normal fuse, it gets a control signal to explode, and then it breaks a
little bit like what you have back in the day with the 12-volt batteries. I think there's also some safety systems in a case of an accident that the 12-volt is disconnected as well. I think there were some
They're
versions.
resettable sometimes. They
are resettable, but I also think there were some examples where they had something like that, what you explained.
Yeah.
But from the idea, it's the same. It should immediately disconnect.
Exactly, but they have to be replaced then. So
yeah, of course.
And they're inside the battery, and that is then the not replaces, but it's a way to replace, I guess, the manual service disconnect. So.
All right, mate. So what about? Can you show us this thing live working, even when it's not inside the car? Do we have the chance?
Absolutely. So what we'll do is we'll have a look at some of the values that you might use to test some of these.
Okay. So I think we need this one then here.
We've got the ohm meter there. So maybe we can just set that up here.
You can check this. I already put it on the right mode.
Got it in the right side as well, because that's also our insulation tester. So we've got two ways to put the leads in.
It's on the right side.
So
12-volt battery.
Exactly. So this is running off the 12-volt side. So let's just start by having a look at one of the tests that we can do here. You see that right there. So we've got our, it's basically very simple, this thing here. So let's have a look.
What's that there? We need your help.
About 30 ohms, roughly there. So now what we'll have a look here is, I'll just put this across here. Go across actually what we can do is put that onto the... So right now, open continuity. See what side we got here.
I try to...
We can see there now.
Just do again the click that our friends can hear it. So I think you hear that's a massive click here because it's a massive relay, so that sound fit.
You can see there that it's got good contact all the way through it as well.
Perfect. And coming back to our problem, when you would weld it shut, you would have continuity all the time.
Exactly, yep. So if it was welded shut, you would see that it's obviously take it out to measure that. Don't do it while it's built in. So
we said now, when we have a welded shut problem, I think that would be up here, right, in this section. Can we figure out, or could there be any problems with the coil?
Yeah, absolutely. So that's the check that we did there as well. Obviously, it's your normal coil. So now these are going to be inside like this. Either we've got either with a connector like that, or with the wiring. There's loads of different types.
Nice orange.
Just a couple that I've got here. The different types that are the way to fasten the cables coming in.
Not quite sure if we answer that question. Where do you find those guys? Are they always part inside the high voltage battery, or could they also be outside the high voltage battery? So just that our friends can
They're usually pretty close to the battery, so mostly in the battery management system.
How complicated is this in general? It's difficult to answer in general, but if you say now we have to, when you get the task, we have to change the relays of the box. So is it like a module which you can take out? Do you have to rip apart the high voltage
Everyone is
battery?
a bit different.
Okay.
So sometimes they come as a complete set where you've got 3 relays together. These are obviously all together, so all separate, so you can replace them separately. Just depends on the situation, but it's obviously very close to the battery because you don't want then cables coming from the battery to the relays, because each time you get further and further away,
losses.
Not losses. It's increasing the risk. So you want them close, so
Okay,
that you've got
yeah.
not so far distance, because if you put a cable in between this, then someone can remove the cable.
True, yeah.
It's all about trying to avoid risk and minimize risk as
That's
much
everything
as
comes
possible.
together. But we said there are also, just as in side excurse, so there are cars which don't have a pre-charge relay or which don't have a high voltage minus relay. Are there some sorts of these cars as well?
So that's what we're starting to see, the latest generation. So what I mentioned before is the positive side. It's a positive, negative on the high voltage battery, and then the very first generation there was a resistor on the positive side. Toyota, for example, then went away from that and they put the pre-charge resistor on the negative side. So that means you've got two negative coils, and then what they've gone now is from the DC to DC converter. So now they've gone just to two coils, and what you've got then is the DC to DC converter, which is what's charging your battery. That's using the 12-volt battery to, normally we're decreasing high voltage into low voltage to charge the 12-volt battery. Now we're going to use the 12-volt battery to increase the voltage and charge the capacitors inside the inverter. And then that way we're saving a complete relay here and the pre-charge resistor and everything there as well.
Which means less components, less weight, less cost for the car manufacturer. So that makes sense for him.
Probably less complexity as well.
Okay, but basically we can say all the relays, even when they have a different shape, they have a low voltage connection as a control connection. They have a coil which is connected to the low voltage connection, and then they have like a separated high voltage line where the drive current is running over, and that's basically the simple setup of each high voltage relay, right?
Exactly, yeah, nothing too
So it doesn't
special
matter
to
if you take this one or if you take this one. Okay, here's basically because of the contactors, because they are pretty small, we actually don't have high voltage running over it, but the basic thing is the same. We have a control circuit and we have a working circuit.
Exactly.
Okay.
So it's pretty simple in the end. What we can perhaps see here is we've got this white here. This is actually a ceramic.
Ah, okay.
So when you're replacing those, just be very careful that you don't
drop it.
Don't drop it. Don't over tighten it as well, because you can crack this housing.
Remember the ignition plugs from the old days.
The spark plugs.
Spark plugs, sorry. Yep.
Yeah,
Spark
exactly.
Plugs.
So.
Okay, but now let's come to the modern thing. As we have talked here about the standard ones, and you said what was back in the day, but I have heard something about smart relays. So what is that? I mean, I think that's also important, especially for the condition of the high voltage relay, but I think you can say a little bit more to that.
So
what I know with the smart relays are part of our Unitrain system. So just quick remember, we have our electric drive, we have the inverter, and we have our high voltage battery. Of course, everything is here low voltage, but we have emulated or simulated a high voltage battery in a low voltage area, but with all the conditions that you can understand how a high voltage battery works. And of course, we have here also some relays in it, and they are smart, right?
Exactly. Well, we can actually do both with this system.
True.
So depending, we can do the conventional
because
system.
you are smart, we have a system which can do both. Yeah.
Try to do as much as possible. So this is actually an older system that a lot of our customers already have from the three-phase, so the inverter and the three-phase motor side.
Can come as synchronous or asynchronous.
Exactly. And what we've done here, this is now a few years old, but it's an upgrade that you can do to the old system. But exactly as you say, you can show what the relay process is, either with the smart relays or the conventional relays. Now, the reason we say smart is they go through a weld check every time. So weld, as in what we're talking before, is about how they can stick together.
So every time means only when you go into ready mode, or also when you shut down the vehicle?
Both sides.
Both sides, okay.
So what I've got here now is I've connected up our oscilloscope to our Unitrain here running on my laptop, and we'll go through and have a bit of a look what that looks like. So on the vehicle here, we'll go to ready mode. So on here, we've also got our brake button. As most modern vehicles, you have to put your foot on the brake anyway. Press ignition.
True.
And what we can see there, I'll turn that straight away so that I can stop this. So
cool.
Right now, if you have a look at the screen here, we can see a little bit of a few different signals. So this is a 4-channel oscilloscope right now. This one right here, this is our pre-charge relay switching on. So
before the story basically goes on. So that's
as soon as I press that start button, this was the only relay that was activated.
and that means basically when everything is fine, nothing else should happen. When just this one relay is activated.
Exactly. So what that is, that's the first check for the negative relay, because our pre-charge on this side is on the high voltage plus.
Yeah.
So if our pre-charge here got turned on, that means and
the high voltage minus would be welded shut.
Exactly. We would see here already voltage building up.
A close high voltage circuit, basically.
Exactly.
But it would go like, it would not go straight up, but like you see it there in this curve, as we have the pre-charge resistance.
The resistor, exactly. So that's our high voltage in this case. So we can see here, I've got different voltage divisions for each circuit. So the B, C, and D are the control side of the relay. So they're running at 5 volts per division. So 5, 10, 12 volts. Our high voltage side is running at 10 volts per division, so 10, 20, 30 volts. So we can see that. So even though they look similar levels, they're actually on they're different voltages.
When there would be now a reaction of the high voltage side,
we'll see that.
Oh, okay.
I can build that in, that we can see what that looks like. So let me just explain this one here. So then that gets turned off, and we see here, this is now, so it's on and then gets turned off again.
Yes, all good.
Now we see here, this is our negative side gets turned on.
Yeah.
And again, we don't see any of the high voltage. So this would now be checking, that's our negative side. So that's now checking to see if the positive relay is welded shut.
And in a normal car without smart relays, they would switch on the negative and the pre-charge.
At the same time.
Just go for it. And here it's really like, so the negative is like earlier switched on than in a normal car. Is that right?
In this case here.
Yeah.
So the pre-charge was on here.
And
turned off again. And the negative was turned on. And that then
then you check if welded shut on the positive side.
Exactly.
Okay, yeah.
So on the positive side. Then what we see here, the vehicle said everything's okay. So let's now go to the everything. Let's turn it back on. Now this is our pre-charge is now being turned on at the same time as our negative.
Okay, now we have the purpose that it's that we have a closed circuit.
Yep. And as soon as that happens, we can see here the voltage build up, and to this point here. Now right here, this is where the car says, okay, the voltage build up, is it all within specifications, all good?
All good.
And then it switches on the high voltage plus relay as well.
But the pre-charge is still on at this time, right?
The pre-charge is still on.
Yeah.
And you can see right here, there's a tiny little overlay overlap between the two. But as soon as that main relay comes on, we can see here, we have now full voltage.
Because there's no resistor, so the resistor doesn't have any meaning anymore.
Effect, yeah, exactly. And then when it gets to that voltage there, everything's good. And it then switches off the pre-charge resistor. And then, so this last little bit here, I've turned it off quickly to get it all onto one screen at the same time. But this part here is ready mode. And then right at this point right here is when I pressed off again. So turn the vehicle off.
So there you see that immediately the high voltage plus relay is shut down.
Yep. But what we see here is the high voltage negative is on for much longer. So the reason for that is because the plus has a chance to be welded shut during
Like we
startup.
explained in the beginning.
Exactly. So there is a slight chance that the plus side.
And then the current wouldn't drop down.
Exactly. We can see that as well. We'll have a
Okay.
look at that, what that looks like as well.
Just before, is there a possibility to explain why you have this different
I was just about
form?
to get to that as well.
Sorry.
So we can see here there's a little bit. That's what we call passive discharge.
Okay.
So there's the capacitors that we spoke about inside. We can see them here, but inside the vehicle they're huge. They're like Coke cans or something like that. Big can. There's lots of them. They can contain lots of power. They need to be discharged. So the first part we get here is passive discharge, and that's where there's a bleed resistor inside the inverter that passively releases that energy.
So electrical energy is converted to thermal energy?
Exactly.
Okay.
Yeah. And then we get active discharge. So that's the part going down there like that.
So, okay, then we see at the very end that the voltage dropped down. So can you just explain that maybe? Because there's a little bit, it looks different from the way it drops down. I think it has something to do with passive and active discharge, right?
Exactly. So we have the passive is that first part, which looks a bit slower through the resistor, but then you've got active discharge, which is then actively discharging the capacitors inside the inverter. So that's done usually through obviously a transistor switching on and charging. It goes through the DC to DC converter to charge the 12-volt battery. So it's not much power, but it has to be dissipated, and so they just put it into the 12-volt battery.
So like passive discharge is a very simple thing, whereas electric energy is turned to heat energy basically.
Yep.
And it could happen then for the active discharge that, for example, it's transferred to moving energy that you turn. Well, an electric motor is not actually turning, but you can give it on one coil, for example.
Exactly.
Right?
Well, what they do is, so what you're talking about is sometimes they'll go through the windings of the motor.
Yeah, exactly. Yeah.
So they'll put it through two opposite windings at the same time.
Okay.
And then just sort of so that it doesn't move, but it dissipates that energy.
Can you call something a standard for nowadays?
I would say it's most likely more through the 12-volt battery than through the motor.
Okay. No, I mean regarding passive and active discharge.
It's absolutely active.
Okay.
Passive is very old school, and only when there's something completely wrong where active discharge can't be used, it will go passive discharge. Now, what we've got here, the active discharge component of that signal that we see there, so that's at 1 second per division.
Yes.
If we have a look at that, that's done within about half a second. It's down to a safe voltage, and that's the case if it's 400 volts as well. Like on a vehicle, it'd be half a second is roughly what's standard. Passive discharge can take 5 minutes when you're talking 400 volts or so.
So even when we go higher now, as we have now Porsche and other cars with 800 volts.
800 volts.
Exactly.
Some of the Hyundais as well.
On the other hand, it's then also a question of being more safe, right? Especially I just think about the first responders when they need to access the vehicle and they have to wait for 10 minutes before they can touch the car.
Exactly. I mean, that's again part of why we do the dead live testing. We verify what the state of the vehicle is.
Of course.
So
well, the first responder maybe not, but yeah, we
exactly.
do, of course.
Yeah, they don't know, so it's better to wait. So
in order to check out, or a good source for finding out if the car you're working on has passive or active discharge, have a look at the rescue card. There it's set basically when the manufacturer is describing how you in an emergency can shut down the vehicle. That's normally set if you have to wait for any time. So when it's set, like I think the Prius 3 was roughly 10 minutes, something like that. There you can think about that this is basically the passive discharge.
And that's always there, and that's a good source of information as well as these rescue cards, emergency response guides is another one. What's the other one called? It's like a dismantler's guide for recycling, vehicle recycling, things like that. It's often difficult to get up-to-date information, but that's a good source. They have to make it available so that firefighters or the auto recyclers, spare parts, all those sort of things, second-hand parts.
All of those.
They can do it in a safe way.
Well, let's get back to that story here. You've shown us the perfect picture perfect.
Yep.
But is there now the chance that you show us a fault?
Yep. So let's have a look at some of the faults. And now that's what's one of the beauty of a system like this is we can put some faults in there and be completely safe. If you start putting faults into real vehicles, it might not end so nicely.
That's another story.
I'm going to start this one up and let's see if we can analyze this and see what's going on. So let me stop that. So if you have a look at that, this is the situation that I was talking about before. So we've got here with our pre-charge relay coming on all on its own. So that's this guy right here.
Yes.
But we're already seeing the voltage build up. So that would be a case of what would be the potential fault in this case?
Well, now you have obviously a closed circuit.
We've got a closed circuit. We've got the positive on this case. It's the positive.
High voltage minus relay must be well shut.
Exactly. So we see it up here, and then we see this passive discharge because active discharge shouldn't be engaged at this point. So it builds up, and we see immediately this passive discharge, and then when the pre-charge comes on again, goes up, and it looks kind of normal after that. And we can see here.
Now it's an interesting thing. When I would be mad and crazy, I could say now, hey, but why is your system going on and is not shutting down? What I expect from a real car. But I suppose that you say something like, when that we have different levels of quality of faults?
I would call it probably risks or hazards.
Oh, risks, sorry, yeah.
Might be the correct terminology there. So
not a native speaker.
Yeah.
Sorry for that. So, and maybe just from my...
Something like this so we get the yellow triangle, for example. So
and
we've
the
got
red one for very serious ones.
We had the triangle, you won't see it there, but you've got a yellow triangle with the lightning bolt in it.
And it's when you said, okay, we have a fault, so the high voltage minus relay is welded shut, but this can't lead to really big problems. I think there are cars which do not have a minus, even a high voltage minus relay, right? So where they just...
I don't know about that.
I think I have seen that. You can comment in the section if you know which cars, if there are cars, then write it. But when I talk bullshit, then write this too. Okay, but this is not such a serious fault, right?
Exactly. So you'll get the yellow warning symbol. I mean, every manufacturer is going to be a bit different as well. But the ones that we've analysed, they'll say this is a yellow warning symbol, go straight to your workshop. So there's a difference between yellow, normally allows you to keep driving. A red one will be, okay, stop.
Shut down. Yeah.
So that's one of the faults there. We'll have a look at the next one. So I'll click on that. So what's happened there is, you may or may not have heard that, but clicking on the pages, let me just show what that looks like. So here we've got all of the different experiments that you see.
So this is now part of our real experience learning course, which we call LabSoft.
Yep.
Or the software we call LabSoft.
But we're not here to do a big sales pitch on our stuff. We're here to show...
Just for your site information.
Exactly. So oscilloscope can bring that up. So I'm going to reset that now. Okay, so what we've got now is a different fault. I'll get you to start it and let's just see what it looks like.
Absolutely.
See if we can work out which one it is. So that looks pretty normal. Let's shut it off now. Okay, there you go. So you've pressed the button. What I'm going to do is press stop there. So what do you think this is the case? So the light blue one here is our negative. This is where you press stop.
Okay. So normally without smart relays, I think both would shut down at the red level.
Exactly. So you're opening one of the relays.
So obviously the high voltage plus relay, and now the minus relay is still shut. And you see that the high voltage is going on, and first, when the negative relay shuts down, then the passive discharge. So he recognizes a fault and he doesn't use, obviously, it's a serious fault as the high voltage plus relay is welded shut. And now it deactivates the active discharge and it uses the passive discharge. And that would be red fault.
Exactly. So we have to reset the system here as well, because that is, so what would happen here is this would be a typical case where the relay has welded shut when it was closed. So when it was controlled, turned on, it's welded shut. And you can see that there in the signal. So the problem is, next time you start that vehicle, you've got a welded plus high voltage relay. And then when you turn that on, you're going to bypass the
resistor.
The resistor.
Yeah.
And the problem with that is that capacitors will act like a short circuit. They can accept so much energy so quickly, you'll literally melt the cables.
Wow.
So that's what's going to happen.
Yeah, okay, when there's no resistance with so much voltage behind it.
Exactly, yeah.
That's high current.
So,
and you see now here on the camera, we have the red fault light and I can't start it again.
Yeah.
No way.
So we have to go out of our system over here. So let me reset that oscilloscope and let's have a look at another fault, see if we can work out which one it is. So,
can you handle that?
I'll see. So on, press off this time.
And press stop. Oh, luckily. Okay, interesting. That looks like a roller coaster.
So what's happened here is...
Start looks pretty normal, does it?
That looks pretty normal, so that's... Well, actually, see how pre-charge is on?
Yes.
Off, but where does the high voltage start? Right here, when the negative should be on its own. So this would be a case that's...
that the pre-charge relay is welded shut?
Possibly the pre-charge relay.
On the first thing, it just reacts normal because we just see the control current basically here. So we can't, the car can't see if the system is if the relay is welded shut.
Exactly.
When it just switches on one relay for itself, right? Okay.
Exactly. So that's why it switches one on at a time, because it can measure the amount of voltage that's building up there.
Yeah.
So it says, okay, what's happened here is the plus side has been switched off, but our pre-charge, now this is most likely not going to happen because the pre-charge has a much lower current.
Yeah. You never know.
You never know.
Theoretically, it can happen.
Exactly.
And the car, up to this point, it doesn't know that there's a fault.
So right here, what it does is like we've seen before, passive discharge starts.
Yeah.
And then it goes into active discharge. And it's trying to actively discharge and it can't get rid of all of the current. So
because you have this closed circuit with the resistor.
With the resistor, so it's not the full current that we've seen before with the plus relay was welded shut. Now it's the pre-charge relay, so it's got the resistor
and
behind it.
And then it stops the active discharge.
And it just gives up. And it's sort of like, okay, there's something really wrong here. And then it waits till it gets to the negative is switched off, and then it just passively discharges till
But before it builds over the resistor, it builds up the voltage again, as we have this closed circuit over the pre-charge relay, right?
Exactly. So passive, active, and then about here it's like, okay, this is not working, and then it switches off active, and then just goes into passive discharge.
That's amazing. Easy. So yeah, we don't do a sales pitch, but this is just what I always love. How easy you can show it with how much, or which basically no effort within seconds.
Yeah.
When I just think about how can you show something like that on a real car, that's basically
it starts getting dangerous.
Nasty, yeah. Especially, you need a broken car. But then you can't show the signal faults. You need a car where all the relays are
What actually worries me is that we're getting into the point where electric vehicles are becoming... it's a part of almost every automotive training now. So we're seeing it all around the world, of course.
All over the world.
What I'm a bit worried about is teachers actually, in fact, trying to do things like this. I think there's a few theories out there that people say the first people to be severely hurt. I think there has been people killed now on working on or messing around on the high voltage side.
Well, when you do Google search for videos, what private persons are doing, as sometimes.
Yeah, okay, that's another story. But I think people trying to understand this stuff, they're going to get a little bit more courageous, and start measuring high voltage, bypassing safe, because you can't access high voltage anywhere without opening an interlock
manipulating
somewhere.
it.
You have to manipulate it, and it kind of worries me about what's going to happen. People trying to simulate these things in real vehicles.
Yeah, but what I really love about this thing here in that case is that you don't need to be in the high voltage area at this level of training in order to understand really complex
principles.
and high level principles, basically.
Absolutely. You know.
Cool.
Let's have a look at this one. The next one, so we're on the next fault now. So start it up and let's see if we can work out which one this is.
Here we go.
So there you go.
Will he hit the stop button?
In time. Okay. So this is where it's got to a point and it's discovered a problem on the for example, the main positive relay. So we can see here, pre-charge looks normal.
Yeah.
But the main relay was never controlled, never switched on.
Okay.
So we got to here. So it could either be it could have tried to been turned on. So before we seen that little kick, the curve going up, and then the kick to the high voltage. It's a little bit more pronounced here that you see on a real vehicle, but we do that deliberately so that you can see the difference between the two.
The red line is running down.
This one right here. So that's right there. So what we seen on the one before is that there was just before the main positive relay would get switched on, and then you get our full voltage. But right here, it's done the pre-charge correctly, it's done the negative side correctly, our voltage is, we've filled up the capacitors, and then it's like the BMS says, okay, switch the main positive relay on, and nothing. And then it's like, okay, there's something wrong, switch the system off, and it goes into passive discharge.
But this has now nothing to do with welded shut.
Nothing to do with welded shut.
It's just a broken, or it could be a wire problem.
It could be the control side of the relay, or it could be the contacts of the relay itself.
Or the coil itself, that the coil is broken. Okay.
Yeah, exactly. So, but as soon as it
here
determines...
Here it's about that there is not a continuously connection, here's no connection.
Exactly, exactly. So, another simple one. We've got a couple more here. Let's see what...
yeah, let's do one more.
I don't know what they are, so we'll work it out. But that's the beauty. You can play with it and see what it is.
If I have such an expert at my side, for sure. Oh, what's that now?
So.
Nothing happened at all. So.
Which one do you think that is? What do we see there?
We see the pre-charge relay, right?
The pre-charge relay, what normally comes on after the pre-charge relay?
Yeah, but we have now here an issue with the high voltage minus relay that he can't switch it on or can't reach it.
Before we didn't control the plus relay, something's happened here on the negative side.
And therefore we have no
So we have
voltage at
zero closed circuit, there we have zero high voltage or the DC link voltage. We just see that, and of course the system's like, okay, nothing.
Can't do anything here.
Yeah.
So that was an amazing insight also now with measuring tools and a LabSoft course to see the different, or see it from a diagnostic perspective, what happens there and how much can happen inside the relays, which basically I thought at the beginning of our discussion here, that's a pretty stupid thing, simple thing, but even here is a lot of smartness inside.
Absolutely. So The control side of it, how it's controlled, sometimes done through the BMS or other manufacturers. Everyone does it a little bit differently, but yeah, it's different ways on how to make life a little bit easier in the end, basically. So, you know, with that intelligent relays, it's just makes it a little bit more safer. I mean, that's part of the, we've seen with our experience with firefighters, police, they were a little bit worried about how this can be, how do they come up to a vehicle that's been crashed? How do they know it's safe? Things like that. So, you know, that's another one point. I'm not sure we brought up that last time either, but these contactors are usually connected to the, not connected to the airbag system, but if the airbag goes off, that's going to be another signal to switch these contactors off as well, so that the system's, again, usually free from voltage after an accident as well.
All right. So just where Daniel says it, if there are any first responders out there, or even body and paint people, and all sorts of these kind of businesses where you have to deal with high voltage vehicle, but you don't have to go in too much detail about it. So just write into the comments, let us know. We have also some training systems where we could go in more detail for this job group. So we are happy to do that. Let us know. For this time, I think we call it a lesson. That was pretty amazing.
So. Let us know what else you want here. I mean, we've got inverters here, we've got three-phase motors, all that sort of thing. So
whatever you want.
We can talk for hours about this topic or the whole topics. Just let us know what you want. Write it down in the comments and give us some good ideas on what we should do for the next time.
Absolutely. Daniel, thank you very much, mate.
Thanks, man.
Have a great time. See you soon and enjoy the rest of the day.
All the best.
Bye-bye.
See ya.